In the beginning of the Do-It-Yourself Off-Grid Solar series, we taught you how to size your system. In the beginning of the series, I also chose a Renogy 1000-watt pure sine wave inverter, and I did so for several reasons. In my case, I was running out of cash to complete the system, and a 1000-watt inverter would handle most of the tasks I needed to complete. Secondly, at the time, Renogy's largest pure sine wave inverter was the 1000-watter, and for reasons I've mentioned in the first video in the series, for which there's a link down below, I wanted to limit the different number of manufacturers. Since the debut of the series, though, Renogy has introduced a 2000-watt pure sine wave inverter, and wanting to take advantage of more capacity, I decided to swap them out. So down came the 1000-watt inverter, and up went the 2000-watt model. For the hundreds of you who have implemented a system from the series, the new inverter is physically much larger, is more than twice as heavy, and has double the number of outlets for a total of 4. Now, an inverter is an optional, albeit almost necessary portion of your off-grid solar system. Your batteries are going to supply you with direct current, and nearly every electrical device we use takes alternating current. If you plan on using just about every electrical device that you own, you're going to need to convert the direct current to alternating current, and hence the need for an inverter. I get tons of questions from the series, and one of the most common ones concerns the use of 12-volt devices and appliances. You see, in the conversion from 12 volts DC to 120 volts AC in the inverter, there's a slight loss of energy. The solution to that problem could be to use devices that are specifically designed to operate on 12 volts. And while there's no wrong answer, I offer two thoughts. Comparing a 12-volt freezer to a standard 120-volt freezer, the 12-volt freezer can cost a significant amount more than its standard counterpart. So while being more efficient, you take a hit in the wallet. Secondly, you have to remember why some of us are building these systems: to have power in a long-lasting emergency. Think of this. If your 12-volt whatever were to fail in this scenario, how would you get a replacement? Lots of people have standard devices, and with no power, they'd be practically worthless. In my opinion, these are the two reasons I chose standard devices and accept the loss in efficiency. The next question I get is sizing the inverter. If you recall from the beginning of the series, I have about 5,000 kilowatt hours of energy stored in my battery bank, of which I can only ever really use 2,500. This 2,000-watt inverter, if used to full capacity, would drain the bank in about 2.5 hours. But that's not the point. Think of it this way. There are certain energy-intensive devices that you might use infrequently for a short period of time, like a vacuum cleaner. If your vacuum cleaner draws 1,200 watts and you have a 1,000-watt inverter, you can't use it. In the first video, I showed you how to use a kilowatt meter to determine your average need for power to size your panels and batteries. You can also use this meter to determine your peak loads or infrequently used high wattage devices. Just plug them in and press the watts button. There's a link below in the description to the kilowatt meter. Also, when sizing your inverter, consider this. Having a larger inverter than absolutely necessary means that even if you aren't running the inverter at full capacity, the stress you place on the electronics is a smaller fraction of the total capacity. It'll run cooler and last longer. The next question I get concerns modified sine wave inverters versus pure sine wave inverters. In my opinion, for this type and size of a system, a pure sine wave inverter is the only way to go. Pure sine wave inverters are more expensive than modified sine wave inverters, but they mimic the power that comes from the grid. With a modified sine wave inverter, electric motors, electronics, LED light bulbs, these types of things may have trouble running if they run at all. And to boot, using a modified sine wave inverter will probably shorten the life of these devices as well. The Renogy 2000-watt inverter is a pure sine wave inverter. When you install your inverter, you're going to have to pay very close attention to cable sizes. If you recall from other parts of the series, low voltages will be at high currents. In the case from the batteries to the inverter, very high currents. 2,000 watts of power at 12 volts translates roughly to 165 amps. Even though we're going a very short distance, 165 amps requires a very heavy gauge wire, on the order of 0 gauge. Renogy ships the inverter with two 4-gauge wires, which will safely transmit the load, but that requires 2 fuses be employed. It also has 2 positive and 2 negative lugs for power connections to distribute the load. Speaking of fuses, you'll have to consider sizing the battery to inverter fuse as well. I initially went with a 200 amp fuse and plan on using devices just over 1,000 watts at any given time, so I'm still okay. But if you want to utilize close to the full 2,000 watts, you have to consider the initial inrush of energy when some of the more powerful devices are turned on. The Renogy 2,000 watt inverter can handle a 4,000 watt surge, which means you have to consider this when choosing your fuse. I also want to make note of an issue I experienced with the 2,000 watt inverter when it arrived. The fans that are used to cool the inverter under heavy load didn't operate properly. The inverter still worked, but I was limited to smaller loads. The reason why I bring this up is because I believe it validates what I thought about the company from the beginning. I was able to call them, tech support was able to troubleshoot the problem and identify a solution, and they corrected it right away. Now, this video won't conclude the series on do-it-yourself off-grid solar powers. There's quite a few videos I still want to make. But if you'd like to see a video on the subject, tell us in the comments and the links below, and check out the Renogy 2,000 watt pure sine wave inverter. If you found this information insightful, drop us a comment, hit the like button below, share this video with your friends, and subscribe to the Tin Hat Ranch channel. Thanks for watching.